All right, let's start. Thanks everyone for coming. Good afternoon. This topic is about observability, a project that I run in one of my clients in Berlin, Elia Group, for those who heard about the company. So who am I? I'm Rashid. I'm a French contractor here since last year, doing a lot of stuff around cloud architecture, observability, and that kind of thing. Working for Elia Group for a year now in observability, building the whole stack from the ground. And the main goal of this talk and this demo is to explain where we started, what are the components that we have chosen, what are the reasons for those choices, and also to explain how the whole stack has been deployed, how it works, the integration between all that. Who has never touched the observability topic? Don't be shy, raise your hand. I will not bite. Okay. So basically, when we think about observability, there are three pillars: metrics, logs, and traces. And the overall idea is to gather as much data as possible to be able to detect any anomaly or bad behavior that might happen everywhere in your cluster, in the network, storage, applications, memory, CPU, and that kind of stuff. Starting an observability project, when you just discover what observability is, and someone says, hey, you have to start this project, most of the time you go to the CNC landscape and you say, what's the observability? And you have this picture. There's a lot of projects, as you can see here. Some are open source, some are not. Some are SaaS products, some are not. So the first step is which one to choose and why. Everything that you will see here is built purely on open source solutions. There's no commercial or proprietary solutions. So why have we decided to build our own stack and not to go to, let's say, a commercial one? Several reasons. The first one is the business of Elia require us to have everything available on-premise in an air-gapped environment, so no SaaS services, not available, and we're not allowed to leverage them. We really wanted to avoid lock-in. Lock-in is not, lock-in is not only about the tools or the protocols or the whatever the solutions. What we tend to see more and more often is as you are pushing more and more data into your SaaS service, the less you would want to go elsewhere. And the reason is pretty simple. If you have petabytes of data, it could take days or weeks to get the data. It's not exactly the same format. You have to do some transformation to put it elsewhere. At some point, you are locked in, even if the solution that is a SaaS service is built on open source solution. As long as you have too much data in it, you're kind of locked in. So this is one of the first reasons that we had this decision. The second one was to have internally all the skills to be able to build this stack, maintain it, evolve it, and have the full control of everything. And the last reason was to obviously avoid as much as possible external dependencies. And what I mean by that is not to have to deal with an external solution that require us to use a single version or a single protocol. This is where we all start. Basically, we just have our cluster and we drop the most famous components, Prometheus, Grafana, and some storage. And by the time that your project grows, you want to add more and more platforms, so you ended up with something that is usually close to this. And as you probably imagine here, this is absolutely not manageable, because imagine that all of those clusters has their own stack built in. If the cluster dies, you lose your observability. Observability is here to help you not losing your production system. So we were thinking about how we should design this platform, what we would want it to use, and obviously how we can make this platform usable for each and any cluster, whoever in the projects wants to deploy an external cluster, let's say 1 to 10 to 100 to thousands. Basically, the overall idea is to have observability stack deployed, and these stacks are able to gather as much data as possible from all of those clusters at once. Back to basic. So we started very, very small, and we tried as much as possible to iterate on the project. We really started since DO, which is for me the R&D stage. About D2, we put a lot of energy into making sure that what we are building is easy to use. Whoever runs this platform, whoever joins the team in the observability topic is as fast as possible able to deploy, maintain, evolve, and create, I don't know, dashboards or components. So some rules that we were very picky in, having something that is highly scalable and as much in the most autonomous way or in the most automation way as possible. Simply said, we didn't want to have to had our hands on what we're building and make sure that it works. There are a lot of pain points. Here, the biggest one, as you might probably imagine, is external storage. And what I mean by that is having something that is scalable in itself is very easy to deploy, and it's, let's say, highly sufficient. Your external storage has its own drawbacks. Growing your storage might not be possible at some point. So either you have the ability to, how could I say, ingest your previous experience into this project and have some clearance saying, okay, I know how this works, and we might need, I don't know, like hundreds of gigabytes or petabytes. Or you have to think about, what if my storage is not able to grow on itself, and what will I do with my stack? Because as long as your storage dies, your stack dies. Being scalable is more everything around Kubernetes. 2 pain points here. I will not spend too much time on this. I really want to focus on core components. The main pain points here are warm up and cool down. Scaling is highly very easy. You have KEDA, you have the HPA, VPA, whatever, not auto-scaling. The main problem here is when you have this job that has triggered, it takes some time. Adding new nodes, even if you're in cloud, it could take 15 minutes. 15 minutes could kill the system. It's really enough to have the system dying just because you are not fast enough to add more resources into it. Cooldown has the same drawback as all of those automatic system has some cooldown mechanism that says, all right, we have passed this storm on the system, so how about we drop the nodes that we are not needing anymore? Very easy, but again, it takes time, and by the time that this node, let's say, is out of your cluster, you might have some issues in the data that this very specific node is ingesting. So you have to think about, I want to be able to create something that is scalable as fast as possible and to have the cooldown period as secure as possible, meaning not losing your data in the process. Scalability, basically, we wanted to be able to add more and more features into the platform without rebuilding everything. Adding tracing mechanism, easy. Adding some FinOps components, do it. If you want to do some sustainability, do it. We really wanted to think it as something that can grow in itself without having to think, oh, I'm using this component, so now that this component is here, I can't change this one. Which triggered us to use basic and known protocols and not dealing with some shiny stuff that we may probably heard about observability. OpenTelemetry, kind of. Several points, flexibility, resiliency. We wanted to have something that is flexible, and by flexible, it's more about having the ability to change every component's configuration without downtime. The business my client does not allow us to have an hour of downtime in the project I'm working on. And if this configuration kills one of these components, and this component takes several minutes to get up again, and by being up again, it triggers some buffers as well, we lose. So how we can make this as flexible as possible, and obviously having resiliency with buffer, caches, and so on. All of those rules push us to have two main concepts: observer, observee. Observer is basically where the biggest part of your stack lives, where you ingest your data, when you will have your analysis component running, your visualization, notification, and so on and so forth. Really clusters fully dedicated to the observability stack. Nothing else is allowed to run on this cluster. The second concept is Observee. Observee is a cluster that you might not be able to have your hands on. This is where you would want to gather application data, metrics, logs, and traces. And by doing so, you really want to have components that have the lowest footprint as possible. You would not want to have any observability component that could jeopardize the production cluster, and at some point, this cluster might not be yours. You have to think about, this cluster is not mine, it's probably my client cluster. I just have to give him basic configurations and some guidelines, and he's able to deploy the very minimalistic components that allows me to get the data I need to offer him observability. This, don't jeopardize the workload. Actually, it never happened on this project, but in a previous experience, it happened. It happened to us. We were not very, picky about the components that we chosen, and one of those components has bad configuration, no limits, gets as much memory as possible, killed the cluster, killed the app, everything was dying. Some bonus I wanted to put in this cluster is bring your own dashboards, dashboard as code, GitOps. Everything should be automated. Everything should be written as much as possible using code. And I want every member of the team to be able to easily create its own dashboards. Meaning, I don't want to see someone from the team at some point that goes into Grafana, ClickOps, and just draw this panel and create this query manually, and so on and so forth. That pushes us to have some upcoming projects I'll talk about briefly afterwards. And the main idea here is to have components, libraries, and library panels into Grafana so that anyone who has access to Grafana and has rights to create its own dashboard has everything built in. If you want to have a CPU or memory dashboard, you have this component, you just add it into your dashboard. If this component evolves at some point because we are changing some configuration or we are adding some shiny color, for example, every dashboard that uses this component will automatically inherit this modification. No copy pasting, no this dashboard is mine and I don't want yours. Everything is really as central as possible. So these are the main rules that I wrote down in the project. And the second part is what are the components that follows all those rules that we have chosen. Speaking about metrics, we looked about Mimir from Grafana, Victoria Metrics, Prometheus, Thanos. We have chosen Victoria Metrics for a lot of reasons. One of the biggest one is his very low memory footprint compared to Prometheus and Thanos. And the second reason is, in our own perception, Victoria Metrics appeared to be easier to manage in the long run than having a huge Thanos clusters. We keep those components in the circle of the projects because they're all able to use Prometheus remote write, so it allows us to move at some point from a different component. If for whatever the reason we are not satisfied with Victoria Metrics and we want to move to Thanos, it's very easy. We have the component, we're just migrating the data, we're using the same protocol, the same remote writes. We just have to slip the component from Victoria Metrics to Thanos, and that's it. Logs, this one on the far left is Victoria Logs, which is not yet GA, should be GA, I think it's in September, sorry. It's getting very interesting and promising. For now, we have chosen Lucky for plenty of reasons. Locky is here for quite a long time. There's a lot of features that has been built. His integration and the way that you deploy Locky is very easy. The configuration is very straightforward. Again, we wanted to keep it simple. I decided to add data pipelines. Put it simply, when we gather data, I wanted to have the ability to add more labels to cut data into the matrix or in the log to scrub probably some sensitive information that I don't want to see in the observer stack. This component that you have here, the tool is called Vector, V-E-C-T-O-R. This is an open source project that has been acquired by Datadog 3 years ago, written in Rust. Very easy to use. I'll show you the configuration afterwards. It really allows us to have these data pipelines that allow us to get all the data, doing some pre-analysis on this, and route the data everywhere we want. If at some point we want to say, I don't want to route my data into Victoria Metrics, but rather into an external Mimir instance that someone has provided, I just change the configuration in Victoria and say, this route changes. Your endpoint is not Victoria Metrics anymore. It's this instance of Mimir that someone has given us. Having, again, the flexibility to really play with the data that we have without being locked into a single solution. Log scraping was different. And what I mean by log scraping is who's responsible to gather all the logs that we need. We have chosen 2 different solutions. Promtail is used, for now at least, on the observer. And the other one, which is over there, is the logging operator. And this one has been chosen to be used in the Observy cluster. The main reason for that is, as the observer cluster only runs the observability stack, we just simply have to gather all the logs at once without having to think about what are they, where are they from, it's local. But at the same point, as those Observy clusters are probably not our own clusters, we wanted to have the ability to have a flexible configuration, being able to say, this component, we will scrap these logs, and this component, we will not, because of plenty of reasons. Enable this configuration, change this configuration, application by application, component by component, again, without jeopardizing the whole system, without having to restart everything at once. Visualization, if you know something that is as good as Grafana, please be my guest and tell me. I haven't found. So we sticked with Grafana, which is really great. There's plenty of features around Grafana, which is pretty cool. Again, we might change in the future. I don't know if one day we will find something very, let's say that gives us more flexibility or more features rather than Grafana, but we'll say that probably next year. I've spoken a lot about automation. This is something that has been really hammered on me since day one of this project. Everything has to be automated. Everything has to be in a GitOps fashion. So we have chosen 3 components. On the far left is the Graphonet library, JSONet, JSONet components offered by Grafana. The funny one over there is Grizzly. Grizzly is a component that is built by Grafana, and the main idea is to write either your dashboards as code using JSONet or in a plain CRD into the cluster. And it allows you to push either the full dashboard or the single component that you have created wherever you want. Basically, we used also Helm to deploy the whole stack. And we just had a look into a cross-plane provider to have some kind of competition with the small beer over there, but for now it has been ditched. We'll see that afterwards. So at this stage, we have chosen everything since the observer to the observee. The last questions that we had, or I had, because I was the let's say the main architect on this topic, is how to make everything running. Bear with me, just a couple of seconds. We ended it with this huge design. On the left, the observee. on the right, the observer. Everything that you have here, we'll go this into details in a few seconds, is how all those components are related to the other, which is responsible about what, where the data is going, why, and whatever. Observability, we have several applications that I have chosen to put here on the graph. Two main components: logging operator, responsible for logs scrapping and shipping, and the VM agent for Victoria Metrics, which is responsible for metrics scrapping. So basically what we do is get logs, get metrics, ship them, as simple as possible. The biggest challenge was here. How to make all those data come in a single point without jeopardizing everything. So the main inputs are shipping and log shipping, and metrics. Everything goes into Victor. Victor has an HA mode. It's totally autonomous. We don't have to deal with it. And using different routes, we can push the logs into Locky and push the metrics into the Victoria metrics clusters, which has several components: insert, alerting, querying, manager, storage, and everything that you have so far. This big picture gives you a glimpse of everything that we have chosen, deployed, configured. Again, everything in a GitOps fashion, no ClickOps, no direct connection to the cluster, and change whatever the value that you have. This part is for the whole introduction. Let's go for a quick demo to show you how we have deployed all those components and also how they, let's say, technically interact with each other. I just do this and built in. Yes. Should be good enough in the back. We're good. All right. So the two clusters we will have a deeper look is DevSpace O, which is the Observability cluster, and Observability Dev O, which is the Observer cluster. So let's have a look. Let's go to see how Loki has been deployed. So plain Helm charts that is run by Argo CD. I'll just show you afterwards. So we have the scripting mechanism that we will ditch because we chosen to use Promptel rather than this one. This one is, so behind this component lives Grafana agent, and Grafana agent is allowed to do everything at once. And we have chosen specific components for specific reasons. We didn't want to have one single component that gathers everything, log, metrics, and traces. So the backend is where we are storing the data. Here we're using GCS buckets. The gateway is, as its name implies, a gateway that allows to do read and write. And you have the read component and the write component. And as you can see, we have the same components. If I look into Victoria metrics, there we go. Grafana, kubestat metrics, not exporters, VM agent because we want to gather metrics from the local cluster itself, alerting mechanism, inserts, the operator that manage everything throughout CRDs. I'll show you that afterwards also. Selection, VM select for storage, and VM storage for the data. One word about VM storage: when you have 3 nodes, the data are not copied into each and any of those nodes. The data is spread. What I mean is, if you want to have full backup of your metrics, you have to back up 3 of them, all of them basically. You can, there's a workaround that you can use. There's a value that is called replication factor, and this value has an impact into how your metrics are stored into all of those instances. If you have 3 instances and you have chosen a replication factor at 3, all those components will have the full data. So you just have to back up only 1 to have the full metrics. The drawback here is when the VM select will have to query, it will query the 3 nodes, and it will get 3 times the same value. So it will need more resources to do the duplication before sending the results to your Grafana, Alert Manager, or whatever. So there's a trade-off that you have to think between I'm able to easily back up everything with a single command. There's a pod that is named VM backup that does this, or leaving it to be spread, more efficient on the platform, but you have harder job into backupping. There's a Victoria Matrix enterprise solution. I'm not here to talk about this, especially because I'm not from Victoria. But they offer an automatic solution that does the backup. Just saying. My dear friend Victor lives himself into, as you can see, these 4 pods, and that's it. Basically, Victor is as much pods as you have decided. You can also leave him to be autonomous into his own scaling mechanism, so fully automated. And if it needs, it starts more. If it doesn't need, it starts less. As easy as that. No external components and so on and so forth. Let's look briefly into the dev test cluster. So we have the logging operator, KNS logging operator. All right. So logging operator, you have 2 flavors. Either you use FluentD, what we have chosen, or you can use syslog ng, depends on your flavor. The component that you will not be able to change is FluentD. FluentD is responsible to get all the logs from all the agents and then ship there to whoever you decided. And it also allows you to have different routes depending on the sources. For us, we have chosen for our needs for now, at least, we have chosen to have one destination, but we could say GitLab is one destination, Backstage is one destination, Harbor is another one, and so on and so forth. Everything is managed throughout CRD, and this is the logging operator that manages this. You update the CRD, it deploys the components, ships them the configuration, and so on and so forth. All these configurations have different concepts. The first one is cluster outputs. And as you can see, I have 2 because I played a little bit too much of this one. The dev, because I'm on a dev environment, and the POC, because I played a little bit too much on this one. This cluster outputs gives you the definition. I probably should not show you that. Not this one. I will avoid that. Basically, this is the configuration that tells FluentD where to ship the data. There are plenty of configurations. You can use authentications to tell FluentD to authenticate to the endpoint and that data. There's buffer configurations. There's really a lot. I'll show you. I have those YAML files. It's just this one is a little bit tricky, so I will probably have a little bit of issues if I show those ones. Gathering data is managed by what they call flow. Flow, in this case, is what are the applications that you want to gather the logs from, and if there's any transformation or a very simple transformation that you want to do on the fly. If I look at this, GitLab flow -o YAML. Very simple. I just added this simple one, and this allows me to say all the data all the logs that has been scrapped from this flow for GitLab when it has been sent to the observer. I have a new label that is called cluster name that allows me to know exactly where the data comes from. And again, you have the matching selector where there's, again, a lot of different options that you can use to make it all work. For metrics, we have the same mechanism. It is called VM service scraps. And it runs exactly the same if I go to, let's say this one, and do Victoria Matrix, Victoria Matrix -o YAML. So this is the configuration. My selector here, I'm just using the label app Gitly because I only want the Gitly component and not the whole GitLab thing. I split them up. My namespace and basically what are the service, which service I want to get my data from. Everything is managed. Let's make it a little bit bigger. I created a Helm charts with a template that you have here. Let's make it probably a little bit bigger and do this. Sorry. There we are. This template crawls a value file that I will show you in a second, and it creates automatically all the VM service grabs definition at once. No need to do some manual magic. Simple Helm charts, value file, and that's it. The value file is this one. So I'm defining what is the application I want to observe and get the metrics from, what are the components, if I want to enable this component or not, and the definition. And then Helm charts does the magic, crawls this file, create all the VM service scraps at once, and allows me to enable or disable any of those components on the fly. Each time you are updating your YAML file and running your Argo CD or whatever to do your GitOps, the VM agent reloads the configuration almost on the fly, nearly real time, and then enables or disables automatically the component. As simple as that. Victoria Matrix obviously has its own value file, and if I go briefly into the remote rights, so you define the endpoint, give him a name again, so that it's easy to manage, and if you have authentication, as simple as that. Basic auth, secrets, username, password, that's it. Logging operator has the kind of the same way. The logging flow is again automatically created with the Helm charts, with this crawling mechanism that I added. And this crawling mechanism uses this value file that crawls into each app, enabled or not, and if it's enabled, it's defining the name, the namespace, the label, and the output. I can send the same data as much as I want to any output. It's either if I want cluster output, which is the case here, or I want application output, which is related to the app itself. It's on me to decide if I want to push everything at once or have some different routes, depending on the application. On the observer, a little bit tricky. So you have Loki, Promptel, Victor, Victoria Matrix. Victor, to show you the configuration, it's pretty straightforward. You have your ingress that you define. All the magic is done here. Let me show you. Where are we? Let's find things. Here. So we have two definitions. We have the sources, which is where Vector gets the data from, and the sinks is where Vector pushes the final data. At the sink level, you are allowed, as you can see here, to create dynamically some levels depending on what you have in the metrics or in the logs. This allows me to have custom labels, to be able to use in my dashboard and not relying on what the component itself brings. One of the reasons that we did this is when we started to play with dashboards and so on and so forth, we obviously started to play with all the dashboards that you can find in the Grafana website, and we, found very soon that you have to recreate all those dashboards because of labels and so on and so forth. So we ditched them all, create their own with our own labels. We have the full control of the labels. We can create them. One word about this, And then I'll show you the Grafana dashboard. Where is it? I deleted it? Yeah, I deleted it. Very, very early in the project, I have a label that basically goes into a configuration that goes into the metrics and creates specific labels from all the labels that I have in my metrics. You might probably have heard of cardinality. In this case, it has killed my whole system because when I wanted to get all of those labels, I have a nearly infinite tree of labels, all connected to each and any of them, which ended to have some simple queries that took hours just to get a simple value. So just a word of advice, don't play too much with this. It's really helpful because it allows you to create some customs labels, but be very, very cautious about the cardinality that you have. One last word about cardinality, it doesn't behave the same when you are speaking about metrics and logs. You have the same concepts, but the implementation is rather different. Everything that you have found here allows us to have, so our Grafana instance, all those dashboards that you have here are automatically provided either by the component, in this case here, Victoria Metrics, or we used a specific configuration in Grafana to tells him to pull the dashboards from an external sources at startup. No ClickUps, no import, manual, copy-paste, JSON, blah, blah, blah. When Grafana started, it loads the dashboards into its own SQLite database. That's it. This one is purely homemade. This is one of the dashboards that we built ourselves, completely as code. All the components that you have here are written in JSONet using Graphonet here and Grizzly. We wanted to have an overview of the cluster itself regarding metrics, its health, logs, if there's any issue. See that you have here some issue here and some numbers. And below, we started to think about, oopsie, where is it? Having some health about GitLab itself. So all the services that you have in GitLab, some queries, and again, logs. Next steps, what we're working on is having specific dashboards as code, again, for all those components. Basically, the idea is if you have here the health that goes below, let's say, 80 or 95, you have a link that appears here automatically that allows you to go directly into the dashboard of those components to gather more information. This allows us also to leverage annotations, and those annotations, I don't know if I have some example here. Yeah, I have some time. Do I have some example here? I don't think. Basically, annotations appeared, sorry for my French. Annotations appears in the graphs, and it allows us to use rules that has been written as code, again, to give some information to the teams that will leverage those dashboards to have some information about what's happening out of the box, directly from the dashboards. And again, having the ability to add some button or some link that gives some information about a runbook that we have written so that the people that uses those dashboards and are responsible for operation, are able to either fix the issue by themselves because it has been known and we have everything built in, or at least some information that gives some guidelines. Again, everything as code. Everything is managed by Argo CD. I will not go into this, but just to show you that we have our Argo CD, we have our definition from a Git repository, and we deploy everything automatically. MRs and so on and so forth. One last thing I wanted to show you, and then we'll have some time for questions, I guess. Yes. Is let's go to this one. So this is what I'm talking about. Alerting is triggered automatically from Alert Manager, and we have this Runbook button that allows us to have some basic information to either fix by ourselves or have some information. If you simply click into this, this is a runbook that we have. So what we're working on right now is consolidating everything that I've shown to you so far, make it stable, goes into productions, because for now we just want metrics and logs, and traces will come afterwards, and put some efforts into writing those runbooks. The basic idea is people that are responsible for those platforms will not be the one that should run it in the long run. So we have to create the documentation that those people can leverage and fix whatever happens in the cluster. What's coming afterwards? A lot of things, traces, on-call mechanism, notification pipeline to add some correlation, some events correlation, not to throw hundreds of notifications at once, but have some logic into being able to limit this notification, because there's tens of components that are dead because of a single one, which is up there, ingress, for example, and so on and so forth. Documentation, sorry, this is a hot topic for us, and in the end, perhaps offering, who knows, this platform to other, let's say, teams internally that might be able to leverage it. One of the reasons that we built everything as code is to be able to ship it to any team or service that wants to leverage it without having the hustle to build it themselves. We built it. If they want to leverage it, get the code, and that's it. And it's time for questions. If I can ask you one, oopsie, what is it doing? Oh, anyway, this is the copy. If I can just ask you to scan this QR code and give some feedback, that would be helpful. And if you have any questions, raise your hand.
Thank you. So my question is, does more than one team use the Observer cluster right now, or is there a plan to do so? And if so, how are you managing who can access what?
In the part of the projects I'm working on, there is the team I'm part of only for now, and we'll see what's coming up after that. We are expecting to leverage multi-tenancy in Grafana to get groups and configuration from our internal IDP, so that we are able to give some rights into Grafana to allow some people to create dashboards or update them regarding code and APIs, and for others just to have a read-only view. And this is one of the topics that we have in the backlog. Not yet. Alerting is expected to be managed by a tool that is called Keep and the on-call component from Grafana. The idea is to implement into Keep some correlation mechanism and leave the notification for on-calls and different, let's say, organization through this on-call component.
I understood that it was a client's request that you built everything from scratch. Would you do it again? Especially thinking that someone else has to operate it in the future?
Main request was you are not allowed to leverage cloud services, so SaaS services, and I have chosen to be able to create our own stack so that we are able to change whatever the component at any time on the project, or not being stuck by some package that we have chosen that has everything built in, but once you say, oh, I don't want this component, but I want to choose it to change it for another one, you get hooked into it. So this is a mix between a very personal decision as an architect and the organization decision that said no SaaS.
So you would do it again?
I will definitely do it again. Yes.
One last question. I have one.
Go ahead.
We, SUSE, acquired Stack State yesterday.
I heard that.
Okay, so they were part of the observability landscape. I heard you said that you didn't want any closed source. Good news, they are open source now. The thing is, you have your stack and everything, but you didn't want any lock-in. So do you do any review of the stack after 1 year, 2 years to see how it goes, or do you have any life cycle plan?
This is an organization decision that exists for now in the backlog. It hasn't been implemented yet. What I haven't said is I'm working on this project since September as part-time, so it's definitely, at least for now, it's not a full-time project. But this has been clearly identified to have a automatic or a manual review of all the components and see if they are still relevant, if we want to replace them, what are the reasons, how, why, when, and why.
Thank you.
Thank you so much.